Which radio source in the sky is the strongest? What is the newest planet found outside our solar system? Will we ever visit an exoplanet? Keep watching to see all about the exoplanet radio emission. In today's video, we will analyze that there is life on other planets. Make sure to stay until the end to find out everything about this. Intense auroral emissions from the smallest stars in the universe could give us a new way to find rocky planets that might not have been seen before. As a planet moves through the star's magnetic field, it can send outbursts of radio waves. Astronomers have studied a similar effect in our solar system. Radio waves that come out periodically when Jupiter and its moon to interact. With the help of a powerful radio telescope, scientists have now found several stars that give off the telltale activity. People say that each one could hold a small world. Its magnetic field sweeps through space as a star spins, interacting with the charged particles blown off its surface and carried away by the stellar wind. If a planet orbits very close to a rotating star, it can speed up the particles, causing a bright flash in low-frequency radio waves. The Low-Frequency Array, or LOFAR, a network of European radio telescopes that work at the lowest frequency seen from Earth, can easily find these flashes. LOFAR is currently doing a wide-field, low-frequency radio survey to look for sources in the sky. Researchers found 19 red dwarf stars with strange radio flashes when they looked through the first data release of 2019. This data covered about a fifth of the sky in the northern hemisphere. First, notice moments from 5 stars because they were similar to what scientists thought auroral fireworks should look like from light years away. These results are in a study published in Nature Astronomy, and a later preprint paper has narrowed the list of possible stars down to 4. The study's lead author, Joseph Callingham, is a radio astronomer at Leiden University. He says, "We see no trends that we would expect if the emission was caused by star activity. All 4 stars are pretty quiet, so they probably won't keep putting out big flares that could be mistaken for an auroral signal from a planet in a close orbit." Astronomers have been looking for signs of planets interacting with the magnetic fields of the stars for years. They have been focusing on small groups of stars that are thought to be best for the search. However, instead of focusing on specific stars, Callingham and his team use LOFAR's blind, catch-all sky survey, making the search fairer. Greg Hallinan, an astronomer at the California Institute of Technology, who is not on the team, says, "This is a cool result. No one has been able to do this fairly before." Even though red dwarfs are small, many of them punch well above their weight, hitting any planet orbiting around them with very powerful flares when it comes to stellar activity. Most of the time, the faster a red dwarf spins, the more flares it makes. But even stars that turn slow, like those in the LOFAR survey, can sometimes burp them out. In the next study, the team tried to determine if the flashes found in LOFAR's radio survey were caused by normal flaring. To do this, the scientists checked the activity levels of their target stars using optical data from NASA's Transiting Exoplanet Survey Satellite, or TESS. One of the 5 quiet stars that had been found before was flaring by the TESS data, but the other 4 stayed quiet. This adds more evidence that their bright radio flashes are caused by planets spinning around them. Benjamin Pope, an astronomer at the University of Queensland in Australia and co-author of the Nature Astronomy study and first author of the second paper, says, "We can pretty much rule out flares as the cause of the least active stars because they don't flare at all. But the scientists still can't say for sure that the signals come from hidden worlds. Other more advanced ways to look for planets have turned up nothing for each star." Pope says, "I've tried to show that they are planets, but I can't." Most of the work to find the proposed planets started last year when researchers announced that one of the 4 quiet stars, GJ 1151, was the first candidate for a star-planet interaction. 2 different teams tried and failed to find the wobbles in GJ 1151's motion that should be caused by the companion suggested by the LOFAR Data A, world with about the mass of Earth that orbits the star maybe every few days and gently pulls it back and forth. It is not great news for scientists who want to find more ways to find and study planets outside of our solar system. Suvroth Mahadevin, an astronomer at Penn State University who helped look for GJ 1151's possible planet, but wasn't involved in the 2 new studies, says that the auroral flashes may be a way for planets to give away their presence. Still, the technique needs to be checked out by 2 groups first. The first time, you want to see a lot of different pieces of evidence coming together, he says. Data from better planet hunting methods should match the periodic radio flashes seen by LOFAR and other similar observatories. Together, these 2 sets of data should confirm the existence of a world. Mahadevin says, Then I feel like you open up the field. It will be our next tool for finding out. For now, Callingham and his team are putting more effort into their search. They have gotten more time on LOFAR to do follow-up observations of GJ 1151 and are still digging deep into the sky survey data from the observatory. In the coming years, improvements to LOFAR and the opening of the Square Kilometer Array, which is even more powerful, will make it possible to find out even more. It seems likely that will name more candidates for auroral planets. As astronomers prefer to call red dwarfs or M dwarfs, they are the universe's smallest and most common stars. They also live the longest and have the most stars. Some estimates say that as many as 75% of the stars in the universe are M dwarfs, and each one can shine for hundreds of billions or even trillions of years. Most importantly, statistical extrapolations from multiple surveys show that almost every M dwarf has at least one planet. If you look at the numbers, it seems like most of the planets in the universe are M dwarfs. No one knows if any of these places could hold life, but studies like Callingham's can help settle the question. No one thinks that any planet inside the magnetic field of an M dwarf will be able to support life. The nearby star would heat these worlds so much that liquid water, which is essential for life as we know it, could not stay on the surface. Instead, they can help scientists find answers to more basic questions about how M dwarfs affect the planets they make. These stars tend to have big explosions, which could wipe out the atmospheres of planets that would otherwise be good places to live. However, a planet with a strong magnetic field might be able to keep its air. In a few systems, astronomers can already tell the difference between planets with atmospheres and those without, but they don't have a good way to measure the magnetic field of a small world yet. Based on the work of Robert Kavanagh, a PhD student, and Aline Vidotto, an associate professor at Leiden University, observations of auroral flashes could do just that, as long as the strength of a flash is proportional to how strong a planet's magnetism is. Vidotto says that studying auroral M-dwarf planets could also determine how dense and fast a star's stellar wind is. The two new studies did not include Vidotto or Kavanagh. These measurements could help astronomers figure out how often M-dwarfs have coronal mass ejections, which are huge puffs of particles that, like flares, can be bad for planets close by. Vidotto says, "I think, with this method, we'll find out a lot more about the star itself." All of this adds to the mystery of whether or not M-dwarfs can have planet that can support life and the bigger question of where in the universe life-supporting planets are most likely to be found. Planets can't live on their own. They live because of their star, said Mahadevin. I think the key to understanding whether or not M-dwarfs could support life is to understand the magnetic activity and magnetosphere of these stars. Leave a big thumbs up on this video if you found it interesting and exciting. And if you are new to our channel, subscribe and turn on your post notification to get updates.